Alrighty, cool. Last panel of the day. Where's the ZK in BitVM? I have a very nice selection of people with me today to talk about that. Let's do a quick intro round first, and then we'll dive in with some questions and what is BitVM and ZK stuff. So Dionysis, if you wanna start.
Yeah, thanks, Dom. Thanks for the invitation. I'm Dionysis. I'm the co-founder of Common Prefix. We're a research and development company based out of Athens, Greece, which is just about as hot these days. And we do both science and engineering of consensus and cryptography, working with BitVM quite a bit. Two of our scientists are co-authors of the BitVM 2 paper, and we love it. We work a lot with Bitcoin and the Renaissance. Let's see what happens out of it. And my background is I'm a cryptographer. I did my PhD in Athens with Aggelos Keyas, and I did my postdoc with David Say at Stanford.
Awesome. Hi, everyone. Thanks for joining us here. My name is Simanta. I'm the co-founder and CEO of Alpen Labs. We're about 30-person team that is working on making Bitcoin more useful. We focus on infrastructure. We're building roll-up and enabling all kinds of expressive contracts, applications through Alpen rollup. And so we've been working on that. I think we're the first maybe team in the space to work on this category. And we're excited to have this on mainnet soon too. So a little plug.
Yeah, my name's Jacob. I work at RiskZero. I'm the product lead for Boundless. The TLDR on Boundless versus RiskZero. RiskZero, okay, we built this cool little thing called a ZKVM. Think of it as a ZK computer. We literally just build a circuit that looks like a CPU. And Boundless is ZK AWS. Now you have all these ZK computers. They want on-demand compute. How do we actually give it to them? So we sort of helped streamline development, but we're also trying to streamline deployment. So awesome applications like Alpen or Bob can just stop thinking about infrastructure and just click deploy.
Awesome, very nice. So I guess my first question that I want to ask is, we've been, ZK has been a topic, I guess, for the last, 10, 20 years, and in blockchain, I think I wrote my first ZK Bitcoin-like client in 2018, and it was horrible and slow. Is ZK now ready for prime time? Can we adopt it into production? Can we secure millions and billions of dollars with this ZK stuff that about 5 people in the world actually really understand? Maybe Jacob, during the ZK VM, you want people to use this. How ready is it?
Yeah, it's all perfect. Don't worry, just kidding. I think our approach to security, when we're thinking about deploying these productions, is very good, right? The team has over a century of combined security experience. Pretty much every engineer we have, right, is ex-hacker, three-letter agency, whatever. I think we need to be pragmatic about this. We, really think the RiskZero ZKVM is ready for production, but we are big fans of multi-prover designs. We're a big fan of Swiss cheesing everything, maybe using a TEE with things, and we want to make sure that we're approaching this in a slow, pragmatic, make sure we're not losing funds anymore. And that's another reason why we've built Boundless. Boundless, right, is a ZKVM agnostic. It's a proof agnostic architecture to where we can start spinning up these sort of multi-proof technology. That's the security side. On the performance side, I would say we're there. We're proving transactions for 1/100th of a cent. We're proving blocks for less than a cent. We're past the marginal return where a user is going to care about paying for the actual proving cost.
Awesome. And then Sims, for you, kind of similar question, because you guys not only tried to solve the super hard problem of using BitVM for bridging, but you're also building a ZK rollup on Bitcoin itself. So, how confident are you in the ZK technology and using that?
I think the core cryptography is ready. It is safe. The concerns, thereafter lie in all the systems that we build above the core math. And whether those systems are safe, I think we should tread cautiously. But your question really reminded me of a very quick story I want to share here. in Bitcoin, like, ZK's old. Like, you can go 2013 Bitcoin Talk forums, and there's this amazing post by Greg Maxwell that just found out about snarks through Eli Ben Sasson and talking in San Jose. And all the developers, the core developers on Bitcoin, were so energized and excited by the possibility of being able to integrate ZK verification into Bitcoin. They talked about, this may seem, read the post, you'll see the excitement. It's like it's a fungibility, scalability, expressivity solution all in one. If we can have Bitcoin start reasoning about zero knowledge proofs, validity proofs, and the post sort of ends in this like really interesting way, which is, but to like prove this one tiny signature, it takes 135 minutes today. But I'm sure the tech will mature over time. And I think that's what we've seen, and I think that's super exciting. We've seen on the proving side, not only has the, as you mentioned, like the performance is there. We can do thousands, tens of thousands of transactions. We can verify that within the speed that we need it. But not just that, we have unlocks on how Bitcoin can start reasoning about these proofs. I think bringing those two worlds together is enormous, enormous opportunity into like actually adding these properties of Bitcoin that's not there today.
Very nice, thank you. Dionysis, you've been a researcher for quite a while, and I think you've been working on a whole bunch of papers that use ZK as a technology. How does it feel like when things now actually get deployed into production that use research you guys been working on for like years?
Yeah, super exciting. I would agree that ZK is mature from an academic point of view for sure. We do have the papers, we do have the technology, and it's been old again, right? Like these things came up in the 2000s, early 2000s.
1980s.
1980s, yeah. I mean the Goldwasser paper, right? But Groth 16, it's now what, 9 years old, right? It's been a while. So things have been maturing. It works. I trust the proofs. I trust the security, I would say, of the implementations. We do have somewhat mature implementations. It's great to see some of the research put into application and action. That's super exciting. The one thing that I'm worried about still, that I think it's not yet there, not there yet quite, is the software stack. So yeah, we have you guys to run our proofs on quite cheaply. Very exciting, and I think that's a big unlock, by the way. I think that was the kind of the prover side of things. The cost of proving was the biggest barrier, and I'm glad you guys are solving that. But on the software side, we don't yet have like programming languages that are still accessible to like the everyday web developer, right? So it should be super easy. It should not allow you to shoot yourself in the foot. You shouldn't have to think like too much about it. It should work out of the box. It should have debugging tools. It should have like tracing tools, all these things. This is a stack that is getting built. People are building it. There are kind of ZK native developers now that are getting acquainted with these tools, even like right when they start to learn to program, right? So that's super exciting. But I don't see yet like the mainstream developer being comfortable with these tools, and I think it's a tooling problem. It's also a community problem. So that's a part that is not there yet. And well, I'm very excited about what is to come there. But shout out to all the PL people, the compiler people. Please, come build these tools.
Yeah, I'll drop some alpha there. So we 100% aligned, right? So what did the ZKVM do? We went from like your team could only write circuits. So like you have to be a PhD in cryptography to write a circuit. Now RISC-V ZKVM, write Rust. With our new version of the circuit that should be coming out soon, we actually like sort of, instead of having like an embedded RISC-V 32-bit architecture, which a lot of ZKVMs tend to use, we're actually going to start exposing Linux kernels to where you could unlock any language. And when we say like, let's bring ZK not to just like Bitcoin, but the rest of the world, okay, there's still like 20 times the developers for Go than there are Rust. So how do we add Go support? There's 1,000x the amount of Python developers. So how do we start bringing this technology to really everyone? We're super excited about that.
Fantastic. We heard earlier Robin talk about like BitVM 3 as the potential successors to BitVM 2. So we go from snark verifier to like garbled circuits. And Sims, I want to kind of point you out. You guys been doing a lot of research on garbled circuits. Like, Is this an entirely new thing? Do we have to re-implement everything we did over the last years in BitVM, and we're back to square one, or where do these gobbled circuits actually lead us?
Yeah, that's a great question. I guess one very confusing point about BitVM is that it is kind of people talk about it both as this like primitive for verifying a snark, a Groth16 snark on Bitcoin, but people also talk about it as this bridge. And these are actually two different things. I mean, one is a light client implementation with a transaction graph on Bitcoin for depositing, withdrawing, and like keeping the peg secure. And that bridge can finally be as secure as it is in terms of reduced counterparty risks. It's one of N because of that primitive unlock, which is the verifier, right? And so these are two different concepts. We kind of call it BitVM2. So a lot of the development that's already has been in place for actually building out that bridge. So building out the transaction graph, building out like the nodes for the operators and the P2P and all of that. We actually more than 75% of it we estimate we'd be able to reuse. It's not something that we would throw away. We would basically take the BitVM2 verifier, replace it with a new thing, make some changes into the transaction graph, and then be able to use that. And so would it make sense to call it BitVM2? I don't think so. It's fundamentally different. It's way, way, way better than BitVM2 in terms of the on-chain costs, in terms of the simplicity of this verifier. But can we reuse a lot of the engineering work that's already gone towards at least that bridge part? Yes. The BitVM2 verifier part, not so much, but yeah.
Awesome, cool, thank you. We talked a little bit about ZK, gobbled circuits, BitVM3. One of our theses at Bob is like BitVM will only really become a thing if institutions also start adopting this. And I kind of want to pose the question to the entire panel, like, how do you see institutions adopting these new technologies being perceived still as very high risk, even though we agree like it's maybe time for prime time, but what do we need to do in terms of education to get actually people that can deploy 1,000 Bitcoins into a BitVM instance? How do we convince these people that those Bitcoins still going to be there and not hacked? Maybe Dionysis, do you want to give a shot at that?
I think the story and the narrative that we have is that this is real Bitcoin, right? It's not some other currency. It's not a different trust assumption. We don't introduce other validators. We don't hop on a different chain. It's not wrapped Bitcoin. It's Bitcoin, right? I think that's that narrative we can sell it. So if people are convinced to use Bitcoin, they are convinced to use BitVM, as long as it has gone through some maturity in the sense that there's people talking about it, people using it, smaller players using it. I see even governments using it, right? Like it has, governments have recently started using Bitcoin more or considering Bitcoin more for storing their assets. And there are needs that Bitcoin itself doesn't cover, right? For example, having multiple institutions participate in a large multi-sig that should have rotation. That kind of thing is very necessary if we want governments to be able to store coins in a way that they want to minimize trust to their own coin holders, right? But I think that's the narrative, nothing more than just that. So it's about building it, deploying it, testing it out, and having testimonials that it works, and that's all we need.
Jacob, do you?
Yeah, I think you have to convince them that the reward outweighs the risk. So how do we show them reward? Okay, get some Bitcoin, get into DeFi protocols, get the yield, show them evidence that you're making money. Okay, they're not going to do anything unless they make money. And then on the risk side, it's really their perceived risk. And how do you do that? With a large institution, your sales cycle is going to be much longer. Okay, so it's probably going to take like 2 or 3 years to get these people on, get them trust. You're going to have to go meet with them in person. You're going to have to go to their New York City office and go get drinks with them. And the second thing, which I think the whole Web3 industry could be, is just having a better, more mature security posture. Not from like a fundamentals perspective, but there's just a way Web2 security people work, and you've got to speak that language and have that documentation. So between that, like social trust and then the security perspective, we can reduce the risk or the perceived risk from their side.
I like that you mentioned perceived risk. I think this goes into the point of like Lindy as well. Like at the beginning, these systems won't have quite as much Lindy, and yeah, you won't be able to close certain types of partners. And so, kind of the wedge here that at least to me, there are a couple of wedges that stand out as like what would be the early beachhead, early set of partners on the distribution partners as you mentioned that would adopt this. I think one of these wedges would be kind of consider how if folks are familiar with Coinbase offered Bitcoin backed loans on their platform, uh, they tap into on-chain markets on Base, but basically you have BTC, they gets sent to CBBTC, goes into the on-chain I think Morpho borrow lend, and these guys have a ton of BTC holders. They're a great distribution partner, and they offer literally the best rates in the industry. Thank you. Because the on-chain lending markets have much better rates than off-chain, right? And what's interesting about that is, okay, other distribution partners are looking at that verticalization play. If you're a custodian, why would you want to send your BTC to CBBTC on Base? Your competitor to Coinbase, right? And so that's kind of an interesting wedge where it's like, okay, this is more safe. We believe it's more safe, but there's also this other value add, which is it's just more neutral. It's an open standard for BTC. If you want to tap into on-chain borrow lend or DEX or something else, either your approach is go through something centralized and wrapped, and you might be competing with that company, or adopt the open standard. And I think that's kind of an interesting wedge to get at because maybe it doesn't reason from security and Lindy first, but something more strategic, and that helps you build the Lindy, and then kind of you can approach it another way.
I would also, maybe I was a bit of a Debbie Downer. I do believe this is the largest opportunity in crypto right now. If you convince, if you can get to a BlackRock or really a lot of other custodians are becoming much larger than Coinbase. I mean, you could be the first 100 bill TVL protocol in all of crypto. It's very exciting.
Nice. And as a follow-up question, I guess, if we look at stablecoins, one of the other really successful uses of crypto and on-chain, but if we look at stablecoins, the two big dominant players are very clearly USDC and USDT that are very heavily centralized. We had DAI and some others that are decentralized stablecoins to a certain extent. We can debate some of this. But they're nowhere near the volumes and the usage that USDC and USDT have. Posing this as a bit of a maybe controversial question, but how are all of us as BitVM teams actually gonna compete with the likes of Coinbase and BitGo, Tron, and against CBBTC, WrapBTC? How are we gonna compete against these assets and make it much bigger than the centralized counterparts? How do we move against companies that have thousands of employees? Maybe Jacob, you want to take that one?
Yeah, I think so. What does USDC USDT have right now? It has a really nice user experience, right? I just use CCTP v2. I'm gonna move 50 million of USDC from Base to Arbitrum to go farm some protocol. It's quite nice. What do they not have? Liquidity. So the current market cap of Tether plus USDC is 175 billion, somewhere high hundreds. The current market cap of Bitcoin is 2 or 3 trillion.
More than 2 trillion.
Yeah, more than 2 trillion. And I would argue the liquidity part is a lot harder. So getting all of that on chain for through USDT or USDC is going to be a much harder problem. Bitcoin, on the other hand, just needs to fix the UX problem, which I think with teams like Alpen and Bob and other people that are taking advantage of the ZK can do. And it's one reason why I'm just so excited about Bitcoin the next year.
Nice. Dionysis, want to take that question as well?
Yeah, I mean, there's an aspect, going back to, I guess, institutional players, that the way that things work, the way Jacob alluded to, right? The way institutions work is a very human trust-oriented aspect. They go meet you, and they want someone to blame if things go wrong. And that's another reason. I mean, I totally agree with the usability aspect. That's maybe the number one thing that we need to solve across the board of all of crypto, right? But if when we're talking about institutional parties, the way that they make deals is, do I know the person? Can I blame them? Can I sue the company in case things go wrong? And that requires a cultural shift if we're going towards decentralized protocols. Now we're going to a protocol that, it's open source. You can assess the risk yourself, and you can have scientists and engineers look at the thing, assess the risk, tell you that, this requires trust to this and this validator set. You don't have anyone to sue, but this is the risk that you're taking, which is based on the science aspect of things. These companies are not used to that kind of thinking, and I think that will take time to change the way that these companies think and take decisions. I'm hopeful that they will start thinking about it in a different way, but it will take years and years.
I think I spoke about this already in my previous answer a little bit, but the other point you made about stablecoins, I think, yeah, stablecoin issuers are not really competitive in any way. I think super synergistic here. They want to compose with BTC. I think they're in the business of how do we mint the most stablecoins and get most usage. And here's, as you mentioned, there's like a 2 trillion plus like liquidity, and ways to compose with more BTC means more usage and more issuance of stablecoins. And I think that it's no surprise. I guess Tether's a huge Bitcoin holder, right, as a company, and a lot of these other companies tend to be very kind of BTC forward. They've been in this space for a while as well. So yeah, I see them as super synergistic, and we're unlocking ways that they can actually issue on Bitcoin and compose with Bitcoin in really interesting ways.
Awesome, cool. Last question, and then I'll pick some of the audience questions as well. Very last question: when are we going to see the first $1 billion of Bitcoin in BitVM? When is that going to happen? I know you're all technical people, so you hate giving timeline predictions, but please do. And Sims, I'm going to pick you because you're building one.
Well, I mean, you just said we're moving away from BitVM 2. Is it going to be BitVM?
Well, it can be BitVM 3, any BitVM, whatever variant.
Yeah. Some kind of new secure peg. I don't know. I have no idea. We're not on mainnet yet. We're planning to be on mainnet beta later this year, and there's a lot of exciting stuff there, and we're really excited for BTC to kind of come in. It could be a year from there. It could be a bit longer, but I'm hoping for within a year of launch, we'll have north of 1 billion BTC.
Cool. Dionysis, do you have an estimate?
Hard to tell. I think I would be less optimistic. I don't think it's happening in a year, given also the timelines of Bitcoin. I would be inclined to say we'll have it when Opcat makes it to mainnet.
Oh, so never. Okay.
That's one way of thinking about it. So, to be honest, we are hopeful about BitVM. Obviously, we're part of BitVM Ankr. We're working on it. We're co-inventors of it, so we're bullish on it. But at the same time, it's not a sealed deal. We don't know if the community is going to use it ever to those amounts, right? We're not seeing a deployment in practice that people are using yet. The protocol itself is going over many new iterations. I mean, there's probably BitVM 3A and BitVM 3B nowadays, and people are working on kind of changing a little bit the ZK aspects of it as well. So there's a lot to do. I would say if things go well, I would be hopeful for 2 or 3 years from now. If things don't go well, I don't think people are going to use BitVM. And in that case, who knows what they're going to use? Is it going to be on Bitcoin even? So really, really hard to tell. I think what would help is if the main chain is a little bit more agile and accepting and pushing proposals and accepting kind of opcodes, soft forks, which is hard, obviously. But that would definitely expedite things.
Cool, thanks. Oh, yeah.
Can I ask a follow-up to you? So caveat, I'm very pro Opcat and like opening the design space just enough kind of to have real covenants, remove one of n even further, uh, maybe cat and mole. That might be all we need. But why do you think that introduction of that would lead to a billion versus without it would not?
No, I think it's more a general comment on the way that the layer one operates and takes decisions politically. So that's just one example. I think there might be other things that we might want from layer one that we could leverage if they're happy to take political decisions and move. Opcat is one example. Covenants that can help on performance. It can help on scalability of things. Can help on the cost for sure. I think we can work around them, but then running tests like Babylon that took $15K just to go through the pessimistic path. I mean, it's cool to see it, but not everybody can do it. It would be nice if it goes quite down and people can test it, right?
I believe it's down to like 350 bytes now, disproving it. This is the next iteration of BitVM 2, but yeah.
15K is less than it takes to play the Arbitrum or OP game on Ethereum. So by like a magnitude.
And I think that's like 73 rounds for like Optimism, and I think it's a 1-round challenge resolution on Bitcoin.
Awesome, cool. I guess we're a bit out of time, so I'll just pick one of those questions, and I'm going to pick the biggest thing to look forward to in ZK in the next 6 to 12 months. And Jacob, what's the biggest thing to look forward to in ZK in the next 6 to 12 months?
A lot of things. I think we are in this like hockey stick era of growth. ZKVM, not only did it make development for ZK easier, it also finally gave someone a stable platform to compound gains over it. So before I write a circuit, and then I probably make that circuit faster, and I add a GPU, but somewhere in that process, I probably wanted to change my circuit, and I restart. Now we have to never restart. And we're expecting like a 10x just in software. By end of year, you could see ASICs, FPGAs come on by end of year. You could see, I think our open market, we expect at least a 5x reduction in cost. So there's always that. That's sort of boring. I am super excited for people to just do like much bigger things. We can generate a proof that's like doing all the execution Ethereum does in a single day now. And I think as you give people more compute historically with Jevon's paradox, people just suck it all up. Your phone is 10,000 times more powerful than the rocket that sent people to the moon. And now I'm complaining that I can't run AGI on my iPhone in my pocket. So people always want more and more. And I think there's just some really exciting applications that'll do more expressive things, hopefully increase yield over Bitcoin on these L2s. So yeah.
Cool, thanks. Do you guys also want to have a stab at the most excited about ZK?
I guess I want to give a kind of very technical scientific answer pertaining to Bitcoin L2s, since some people are asking that. I'm very excited about the garbled circuit construction, but there are some technicalities about proving that you did your garbled circuit correctly. So there, I'm curious if we can use something that is a variant of Groth16, and we can design it in a way that is compatible with whatever schemes are used to construct the circuit, so that we can do much cheaper proofs. And I think the comment there is that the people who design ZK typically are one set, and then the people who understand the intricacies of script are a different set, and there's no intersection there. So if you look at the Groth16 paper, it's constant size. The verification is just one whale pairing check. But then when you write this in script, it's crazy expensive, right? So if we go to the ZK people who are these theoreticians, and we tell them, please look at these concrete gas costs and design something that works, I think that's something that can improve these costs significantly, and we should be looking at that. And that's like ZK construction at the theory level even, right? So I'm hoping that in the next 6 months to a year, we might get that if we talk to the right people and involve them and tell them, what is this programming language? What's expensive? What is not expensive? Can you figure out a primitive that you can use different from whale pairings that can be expressed in these languages? I think we might have an innovation there that will bring down the cost very significantly.
I completely agree with that framing of the ZK scholars and the Bitcoin wizards. I would maybe even add Rust Maxis to that, and that's kind of your dream team to be able to do this. And yeah, we should chat after as well, because this is also the line of work that we expect to have a paper soon in a week or two on exactly the, a variant of Groth16 that, as you mentioned, that brings down the cost significantly in Bitcoin.
Awesome. And with that, we're closing this session. Thank you very much, Jacob, Sims, Dionysis. Thanks for joining us. And everybody who has more questions, please approach us afterwards. Happy to answer. And thanks all for coming. This is the last session of today, correct, Nick? Yes, cool. Drinks, ask questions while drinking. That's much better. Thank you.
Thanks, guys.